In section 7.3 and 7.4, we're going to talk about adding and subtracting rational expressions. And if you remember from working with fractions, it's a lot easier to multiply and divide fractions than it is to add and subtract, because to add and subtract you need a common denominator. So first, we're going to talk about adding and subtracting if you already have the same denominator. And in that case, you just get to add and subtract the numerators and then keep that denominator. So if you already have the same denominator, it's sort of easy, right? So you say, okay, these have the same denominator, so that will be my denominator. And then I would just do x minus 7 minus 2, which would be x minus 9. And then you would always check to see if you can reduce. We don't have a factor of 3 in the numerator, so we can't reduce this, right? So if this had a 3x, then we could do something, but as it is with x minus 9, we're just stuck, right? So this came from x minus 7 minus 2. B is a little more interesting because those denominators don't look the same, but they are the same term subtracted in the opposite order. So what we can do is make them the same by changing the sign on the second one, or the first one, but it's probably easier to change the sign on the second one and make both denominators x minus 7. So what we can do, so remember these are the same, but they're just opposite signs. So we'll leave the first one the way it is, change this to a plus, and make this denominator x minus 7. And now we have forced them to actually have the same denominator. Right, so we did two things. We changed this to a plus, and we changed the order in the denominator. And now that we have a common denominator, we would just say, okay, my new denominator will be x minus 7. And I'll add the numerators, which would be 6x plus 5. And then I would look to see, is there anything I can reduce? Not really. There's no factor I can take out of the numerator, and there isn't a common factor here in the numerator and denominator. So that's the final answer. Right, so to be able to add or subtract, we have to have a common denominator. So if we have a common denominator, just add the numerators or subtract them. Otherwise, we have to find the least common denominator. And before you can figure what the least common denominator would be, you have to factor all the denominators. So that's the first step, factor the denominators. And then this says the least common denominator would have to include all of the factors that are showing up in any denominator, and you have to use the highest exponent that appears in any of the denominators for each factor. So my factors of the denominators are 3 and x squared, and 3 and 5 and x to the 4th. So I need a 3, because each of these has a 3. I need a 5, because one of them has a 5. And I need an x, and the exponent I choose has to be the highest one. So x to the 4th. So the least common denominator would be 15x to the 4th. And that's all we were asked to do here, was find the least common denominator. So that's what it is, right? So you take any factor that shows up anywhere. So we've got 3's and 5's and x's. And then if we have to choose an exponent, we take the highest exponent that occurs in either of the denominators. Okay. Alright, so in the next one, again, I look at my denominators and try to figure out the factors that we have. The first denominator looks like it would factor as 2x plus 1 squared. The second denominator looks like it would factor as, let's see, probably a 2x and a 4x. And what else do I need here? 1 and a 3? Is that going to work? Both with plus? I think so. So my least common denominator has to have, I see factors that are 2x plus 1 and factors that are 4x plus 3. So I need those, and because one of the 2x plus 1s is squared, I'll use a square. So that would be my LCD. Right? So we need to be able to find the least common denominator to be able to add and subtract fractions. So that's the first step in adding and subtracting, is just figure out what the LCD would be. And then it says rewrite each expression, each individual term, with the LCD as the denominator. So this is going to involve multiply by forms of 1. Right? So we'll multiply by factors, factors that involve the numerator and the denominator that are matching. Once we have the LCD for each expression, we can add and subtract the numerators. Right? So example A here is actually like the second example we did. These look like they aren't the same denominator, but really they are, just in opposite order. So the best way to deal with this is just to say, let's have the LCD be x minus 2, and rewrite this with a minus, and change the second one, change the order. Right, so we have to change the sign when we change that order. And then we can say 3 minus 1 over that same denominator. That's just 2 over x minus 2. We can't reduce those 2's because we don't have a factor of 2. So that's our final answer on that one. B is a little more complicated because these are not even close to the same factors. So LCD would have to have an x minus 3 factor and an x minus 1 factor. So keep in mind that each of these denominators has just one factor. There's not an x and a negative 3. Those are terms, but the only factor involved in any multiplication here would be x minus 3 and then times 1, if you want to think of it that way. So what we want to do is rewrite each of these with that denominator, right? So the first one already has that denominator. So we multiply by x minus 1 over x minus 1 because that denominator was missing in x minus 1. Right, so we're multiplying by a form of 1 right there. And the second expression, second term, is missing an x minus 3 in its denominator. So we do this to get a common denominator. Again, multiply by a form of 1. Now they both have the same denominator, so we'll rewrite the whole expression over that same denominator, and we'd have 2x minus 2 minus 4x plus 12. Right? So I'm expanding the numerator so that I can regroup and combine like terms and reduce if I need to. So when I combine like terms, that's negative 2x plus 10 over x minus 3 times x minus 1. I can take a negative 2 out of this times x minus 5, but that doesn't make it anything I can reduce. So you always want to factor if you can and try to reduce, but can't really reduce. So there's our final answer. On to example C, which I think, oh no, there's a few more on the next page. Example C. Let's see. Notice the first two denominators are already factored, but the third one we can factor like that. So our LCD would actually be just 2 minus x times 2 plus x, because that would involve the first denominator, the second denominator, and the third denominator are all included there. So the third denominator already has the least common denominator. This first one and the second one are each missing a factor, right? So we would have x minus 3 over 2 minus x. That needs to have some additional factors here. Let's write those in blue. that's missing the 2 plus x. So we'll do like this. The second one, keep in mind that there are implied parentheses. Anytime you have an expression like this, there are parentheses that aren't written but are implied around each numerator and denominator. So it helps to actually write those in, I think. This is missing the 2 minus x. And then the last one is not missing anything, so we can just leave that. But let's write it with a factored denominator. So we can see now they all have the same denominator. So it's going to be a big giant numerator and then this denominator like this. So I'm going to expand the numerator and put all this stuff together. So this would be x squared. Let's see, minus 3x plus 2x would be minus x minus 6. And then I'd have minus, let's see, negative x squared. I would have to multiply before I distribute that subtraction. This gets kind of complicated. But a negative x squared minus 3x plus 2x, another minus x plus 6, and we'll subtract that whole thing, plus x plus 6. So I need to do some combining like terms in the numerator up here. So I've got 2x squared, a minus x and a plus x, and then plus another x. So that would be plus x, a minus 6 and a plus 6, and then a minus 6. So minus 6. And then, let's see, we would try to factor the numerator again if we can. Does it factor? Yep, a 2 here and a 3 here, with a plus on the 2 and a minus on the 3. So what we've got then is these can reduce, and this is addition, so these aren't opposite, they're actually the same factor, right? They're just matching. So if there were subtraction, we would reduce this to -1, but since it's addition, it's just a factor of 1. So our final answer should be 2x minus 3 over 2 minus x. Okay, a couple examples here on the next page. So again, first thing is to get a common denominator, but before you can do that, you just need to know how this factors. This would be, what, x plus 2, x minus 4. This one would be x minus 1, x minus 2. Let's look at that first one again. I think I've got my signs backwards. So it should be x plus 4, x minus 2. That looks better. So now they actually have one factor in common. So the LCD would be, has to have an x plus 4, has to have an x minus 1, and it needs to have an x minus 2. But just one of them. It doesn't need x minus 2 squared because there's only one factor of x minus 2 in each denominator. Right? So you don't want to have extra factors that you don't need, because then it's going to get to be just a lot more writing than you need, and it'll look more complicated than it needs to be. Right? So our first step is to build up to that denominator. So if this first factor, or first expression, sorry, had the x plus 4 and the x minus 2, but it was missing the x minus 1. So we'll multiply by x minus 1 over x minus 1. And the second one has the x minus 1 and the x minus 2, but it is missing x plus 4. So we'll multiply by x plus 4 over x plus 4. And then we say, all right, then I've got this expression with this denominator, these factors. In the numerator, I'm just going to expand, so I'll have 3x minus 3 plus 2x plus 8. Combine like terms, so that's going to give me 5x plus 5. Keep that denominator factored because you want to be able to reduce if you can. And then in the numerator, you can take out a factor of 5, which leaves you with x plus 1, but it doesn't really help us because that's not the same as any of our denominator factors. So we would leave it just like that. Remember, x plus 1 over x minus 1, it looks like we could reduce it, but we just can't. They're not the same, and they're not opposite. All right, example E, if we factor the denominators first to figure out the greatest common factor, this first denominator factors as x times y minus x, and the second one factors as y times y minus x. So our LCD, this time, we need an x factor, we need a y factor, because the first one has an x, the second one has a y, and we need one factor of y minus x, because they each have a factor of y minus x. So building up to that denominator, the first expression needs a y, so we'll multiply by y over y, and the second one is missing an x. So we'll multiply that one by x over x to build up each term to the common denominator. That's going to look like then over the same denominator, x times y minus x, we'll have y squared minus x squared. Difference of squares, so we can factor that. So don't cross off the x's and y's yet. We have to factor this first and then reduce. So that would be y minus x times y plus x over x times y minus x. So when we factor and then simplify, we get this. Y plus x over x times y. One more example. I think that's it. Yep. One more example. So we've got, first again, factor the denominators, which means write this as a product. So x plus 2 times x plus 3. And here we have a difference of squares, which would be x plus 2, x minus 2. So your LCD, first just figure out what it would be. Needs to have one x plus 2, since each of them has an x plus 2. Also needs an x plus 3, since the first one has one of those. And needs an x minus 2, since the second one has an x minus 2. Build up to that. Multiply by the right form of 1 to include the missing factors in each expression. First one needs x minus 2 over x minus 2. The second one needs x plus 3 over x plus 3. Alright, so anytime you're multiplying by something in the denominator, you have to do the same in the numerator, otherwise you're changing the value of the expression. And we also have to keep the denominators, right? If you're adding fractions, you have to keep the denominator in the mix, so we can't just have these denominators disappear. So we're actually building up to the least common denominator. Then I've got, what, 3x minus 6 and x plus 3, which means that's, what, 4x minus 3. And that doesn't factor at all, so we know we're going to be done at this step. Nothing to factor and reduce. So there, we've got adding and subtracting fractions, and we've also talked about multiplying and dividing. So we've got all the operations on fractions that we need.